then the next thing that we need to do is to come down and select a part. Now we uploaded one part into our parts library, so that's what's available here, and you just come over and click add, and then it will come up here and you can see that it shows as the part that you are simulating. It does take a little bit of time for this to load sometimes, and then you can come in here and you can rotate the part. As you rotate beyond to where you would just be seeing the base plate, then the base plate goes away and you're actually able to look at the inside of the part. So you can go see your part, make sure you've got the right part, and then you just come over here. We created a template, so if you want to preserve these inputs for the template, you hit save, and then if you want to actually start the simulation, then you hit start simulation. And that brings you back to this running simulation screen where you can see the real-time updates of what's going on with your simulation and all of your inputs and things along those lines as well. And then there's also a log file. Right now it's just running pre-processing, so there's nothing in the log file. But then if we want to go back and look at what's happening, now we have this template saved. So if we wanted to come back and run something again, we can come back and make modifications, and then you can either save a new template update, or you can just run a new simulation from that same template. You have this here where it shows you what's going on with your simulation, and then completed simulations are over here. And in order to, this is going to take a few minutes to start up the server and run the simulation. And so in order to see the results, I'm actually going to switch over to a different screen where we're looking at something that I've already ran. And we've got the simulation results. So this is what your results page will look like. It has your runtime, your result ID, and the inputs that you used from your template, as well as the outputs that are happening over here. So your stress and displacement are in a VTK file format. So you'd come over here and hit download. It'll download a VTK file, which then I view that through ParaView, which I'll show you in just a moment. You can also get a CSV file for the specific locations and magnitudes of your blade crash locations. And then you get 3 support files, a uniform thin wall support, which is just geometry based, and then your 2 that say optimized are your support structure outputs that are based off of the stress that we predicted in the part. And then you've got also a position part, which just is your STL file positioned and aligned to the way that the simulation was ran.